Hello everyone, welcome to our Ask Geology group, a whole new way to understand our Mother Earth. So in this today's numerical, 7-minute numerical, we are going to discuss about one geophysics question which is asked in Csir-Net 2019. Okay, and I think this is one of the most derived and most common question that is being asked, and it is important to understand the concept which is present behind it. Okay, so the question is the travel time difference between the P wave and S wave arrivals at two stations A, B are 3 seconds and 4 seconds respectively. While the difference in the P wave arrival time between the same station is 1 second, then what is the ratio of P wave velocity to that of S wave velocity? So here we just know that when one earthquake is being generated in the focus, okay, that travels, okay, and the energy that travels through waveforms, okay, and those are called your seismic waves. And those seismic waves are, if they are body wave, then they will be P wave and S wave, and surface wave, relay wave, these are some surfacial waves. Okay, and all of you know that the velocity of P wave is the highest. Okay, so it is the first wave to arrive on the seismic station, and S wave, that follows the P wave, and surface wave, that is the most devastating. Okay, but it is the slowest one. Okay, it is actually the slowest one. So in this section you can see that if earthquake is generated below, then that starts traveling, okay, and these are the seismic station, okay, these are the seismic station. You can see that these are the waves, okay, these are the waves. And my another question is, why they are called seismic waves? You just write down in the comment box, huh? So why they are called seismic waves? Okay, elastic property or seismic waves, and these are called also elastic waves. And what is the difference between the seismic wave and elastic wave? So in this section what they are asking, that the travel time difference PS is in two stations is 3 seconds and 4 seconds. Let us just write down, okay, and we are going to use this travel time difference. Okay, this D is your epicentral distance, and it is in kilometer. Okay, always remember. And Vs, velocity of S wave, velocity of P wave, and Ts minus of Tp, this is the time difference. Okay, this is your travel time difference. Okay, this T represents your time. Okay, so what is the data given? Let us see data given. What we have given, that Ts minus of Tp, okay, Ts minus of Tp of A is equal to 3 seconds. Okay, let this station to be A, this station to be B. Okay, when this seismic like the sudden strain energy that got released, then that will come to the A station first, then it will come to the B station, and in between A and B there will be a time difference. Okay, so starting from A, okay, now the P wave will come to A, then the S wave will come to A. Okay, so within this A, at station A, there will be a difference of this travel time of P and S wave. It is given that this one. So Ts minus of Tp, or the travel time difference of P and S wave at station A is 3 seconds. Okay, and another given, Ts minus of Tp is equal to, this is at B station, that is 4 seconds. This is the first question. Travel time difference between P and S arrivals at two stations A may, that is 3 seconds. This is Ts minus of Tp at A, this means A station, seismic station, that is 3 seconds. Ts minus of Tpb, that is 4 seconds respectively. Okay, now here's another information. While the difference in the P wave arrival time between the same station is 1 second, that means P wave arrival, okay, while the difference in the P wave arrival time between the same station is 1 second. So this is travel time of P at A, sorry, travel time of P at B minus of travel time of P, TP, okay, at A is equal to 1 second. It is clear? While the difference in P wave arrival, TP, this is P wave, this is also TP, P wave, arrival time between the same station, between the stations, means between A and B, okay, and B is, we are considering B to be far away, that's why it will take longer time, and the difference is given to be 1 second. Difference in P wave arrival time between the same station is 1 second. Up to here, no doubt. These are the data given in the question. Okay, now we have to calculate what is the ratio of P wave velocity to that of S wave velocity. That means Vp by Vs we have to calculate. Okay, and this travel time distance or epicentral distance formula, that is going to be used here. Okay, so just write down what is given, that is Ts minus of Tp is equal to D, that is equal to D 1 by Vs minus 1 by Vp. Okay, so this Ts minus of Tp, we can just write down it, Ts minus of Tp. This is basically, sorry, this is actually the main formula. Okay, this is the main formula, and we have to derive some formula from this main formula. Okay, from this we have to derive some other expressions in terms of P and S wave velocity. Okay, so this is Ts minus of Tp is equal to, Ts minus of Tp is equal to, can I just write down here this Tp Vp by Vs minus of 1. Is it fine? Is it fine? Okay, so ये हम कैसे लिखे? Now you can see that if I just take common, okay, if I am just converting, or I am just deriving one formula, the travel time difference in terms of only Tp with respect to only P. Okay, so ये जो formula है, so D 1 by Vs plus of 1 by Vp. Now in this formula, what I just took, I took the Vp as common. Okay, I just took out the Vp outside, D by Vp. Okay, D by Vp. So I have to multiply that Vp inside. If I just divided Vp in outside, then Vp by Vs minus of Vp by Vp. Simple. I just multiplied Vp and divided Vp. Unit is also same. This Vp will cancel out. It will be value 1, and D by Vp is equal to Tp. Okay, this is the distance traveled and this is the velocity. Okay, V is equal to S by T, we know. Velocity is equal to distance traveled by time. So if this time is equal to S by V, okay, this is the distance traveled by the wave and this is the velocity, so that is your T, time. Okay, so here in this case D by Vp, in place of D by Vp I can write down Tp is equal to Vp by Vs is there, Vp by Vs is there, minus of 1. This is actually present here. Okay, so no problem. Ts minus of Tp is equal to Tp Vp by Vs minus of 1. Okay, let it to be the first equation. Okay, let it be the first equation. अभी second equation क्या होगा? Okay, now we just see what it has given. Ts, sorry, now this is Ts minus of Tp at station B is equal to travel time b vp by vs minus of 1. Okay, this is, let this to be equation 2. And another simple equation, ts minus of tp at station A is equal to, this is ta, this is your vp by vs minus of 1. Okay, this is equation 3. Here I derived, in this case I derived the travel time difference in format में कौन सा TP and TS. With respect to P and S format में I just derived and I just shared those things with respect to B station and A station. These are the two equations I just got. Okay, only substitution, nothing else. So if now what I will do, if I just subtract these two things, because they have given that the travel time difference between A and B, okay, somewhere it is given, you can see the travel time difference between P and S arrival, that is 3 seconds and 4 seconds respectively, and this 1 second is given. Okay, so I can just write down Ts minus of Tp B, it's Ts minus of Tp B minus of Ts minus of Tp at point A. Okay, this is equal to Vp by Vs minus of 1, common ले लेंगे, then Tb minus of Ta. Okay, this Tb minus of Ta is given to be 1 second. Here you can see the difference in the P wave arrival time. Okay, Tb minus of Ta of this is of P wave. Okay, that is 1 second, that is given. This is Tb, यहाँ पर लिख दो Tpb and Tpa. Okay, this is Tpb and Tpa. This is given to be 1 second. ये तुम्हारा given है. And Ts minus of Tpb minus of Ts minus of Tpa, ये हमको दिया हो गया है. कितना है? Ts minus of Tpb B स्टेशन में कितना है? That is 4 second. Okay, Ts minus of Tp, that is 4 second. Ts minus of Tpa station में, that is 3 second. So this is 4 minus of 3 is equal to, we have to calculate Vp by Vs, we have to calculate minus of 1, and this value is 1 second. Okay, so simple, 4 minus of 3 is equal to 1 is equal to Vp by Vs minus of 1. ये तो multiply हो जाएगा, 1 ही रहेगा. That implies Vp by Vs is equal to 1 plus of 1. They will go that side. This is 2 and this is your answer. It is asking now. So what is the ratio of P wave velocity to that of S wave velocity? Velocity of P by velocity of S. So this is the answer. Okay, so here what we did, that starting from this equation, okay, let me just change the color. Starting from this equation, this epicentral distance and seismic wave velocity travel time difference, it is related to this travel time difference. Epicentral distance d, Ts minus of Tv, this is the travel time difference of P and S wave, and these are the respective velocity of S wave and P wave. Okay, and from this central or from this main formula we derived this one. We've derived this one in format of Tp, in P wave velocity format में निकाले. If ये S wave में अगर निकालते तो what would be the equation? Then this would be Ts 1 minus Vs by Vp. You just try. Okay, now when you in Tp format, this is actually the equation, and in if we just calculated Ts, because here it is asking about the ratio of it is given that P wave arrival velocity data दिया हुआ है. Okay, difference in the P wave arrival time. If it would have given some S wave arrival time difference, then we will use this equation. Okay, this lower green color equation. Then we have to just plot this, then further these two equations ना, these are derived equations. Okay, for this question तो इसमें हम Ts minus of Tp, यहाँ पर B है, ये Tpb नहीं लिख के यहाँ पर Tsb लिखेंगे. If this question यहाँ पर जो तुम्हारा P wave arrival time जो दिया हुआ है, if it would have given in S wave format, then we would have used this the green color one. Okay, this green color formula. Okay, starting from the main formula, we have to derive something, nothing else. Okay, then accordingly, then we will have to solve these things, no problem, and the final answer is 2. Okay, let me give additional information about what is seismometer. Okay, seismograph and seismogram. Seismograph, it is basically the instrument. Okay, seismograph, it is not like a graph. Okay, this is not. Seismograph means it is seismometer, the instrument that is used to detect or record the earthquake. And seismogram जो है, gram is basically the graph, the output. ऐसे सिग्नल आता है ना, this is basically the output. Now this seismograph, this instrument, graph थोड़ा उल्टा है, this is actually the instrument. Seismograph is the instrument, and seismogram, now you can see that this is actually a paper. Okay, this paper, when this paper comes out, it just get the recorded form, recorded data in graph. In graph जो रहेगा, that is called your seismogram. That is the measurement. Okay, that is the measurement, that is seismogram. And earthquake related में हम बताते हैं एक magnitude क्या होता है and intensity क्या होता है. Okay, magnitude, it doesn't change. Okay, it is size of the earthquake, where it occurs. It is important to mention this particular last terminology, that measure the size of earthquake at its source, and starting from the source, wherever it goes, is its magnitude that doesn't change. Okay, so magnitude is independent of your distance from your epicenter to some distance away from the epicenter. Okay, so magnitude कहीं हम बोलेंगे, this is if it is 6.8 magnitude ना, this if at this point earthquake is happening, and at this point which is around 50 km away, then the magnitude will be same. It is 6.8, here also 6.8. Magnitude will remain the same, but the intensity will change. Okay, intensity means intensity. Okay, intensity, the amount or the measure or the amount of shaking of a particular location, कितना shake हो रहा है. Okay, now when the energy will dissipate ना, then it will have some devastating part at this point which is very close to the epicenter. Okay, then the intensity or the devastating nature, that will decrease away from the main location where the earthquake that was located. Okay, so and intensity, like when we just go away from the epicenter or the focus or the epicenter, then the intensity decreases. Okay, and magnitude measure करने के लिए we have Richter scale. Okay, and for intensity, this is modified Mercalli scale and Rossi-Forel scale. These are some other types of scale which are used to measure the intensity of an earthquake. And earthquake के बारे में और एक चीज़ क्या है? Now this earthquake, okay, कैसे फॉर्म होता है earthquake? How this earthquake happens? Earthquake, this is natural phenomena where the accumulated strain energy that get dissipated. Okay, sudden release of, this is actually sudden release of accumulated strain in rocks. Okay, and maximum how much depth this earthquake can happen, still till now अभी maximum depth क्या वो होता है, उसको हम बोलते हैं Benioff zone. All of you might have known Benioff zone, because यहाँ से, okay, after around 700 km, this zone is the base of this Benioff zone is around 700 km, and seismicity is identified from this particular 700 depth. Okay, so this is all about this numerical. I hope this numerical will help you to tackle some other types of problems, because this derivation is important. And remember one thing, that from direct formula questions are being asked very less. So from that direct formula you have to derive something. Okay, And if you derive something like this equation 2 and equation 3, if I just made a subtraction here and I just go to the answer. That's why, so try to derive some other formula from the main source and try to solve those questions accordingly. Okay, so thank you very much. If you are very much interested to join our group, then you can call to these numbers, mail to this mail ID. We have our link tree given in the description box. You can go and just visit our website for more information. And thank you, have a good day. Thank you.